Snotwind News. I'm Saari. Today we're going to go to Bailey Christopherson for an exciting story on Newton's first laws of motion.
At Compass Academy, interviewing students from Mr. Taylor and Mrs. Hadley's science class. I'm here with Gisela Hernandez on Newton's first law of motion. Gisela, for those of us who don't know what that is, will you please tell us what that entails?
Yeah. Newton's first law of motion states that an object in motion stays at motion, an object at rest tends to stay at rest unless acted by an outside force.
Wow, that seems really cool. How does that relate to your group member dropping an orange?
It relates to Newton's first law of motion because the orange is at rest before we dropped it, and gravity acts upon it, causing it to be in motion. And then it was in motion until it was acted upon another outside force, which in this case would be the table, making it come to rest.
That seems like a way fun to prove how science actually works. Thanks, Gisela. Back to Ashlyn in the studio.
Well, doesn't that look like a blast?
This program was recorded by Compass Academy Broadcasting Station.
This is Saari from Snotwind News with an exciting new story about gravity coming from Compass Academy's Science, Fact, and Fiction class. They have been working on this project for a while, and it's called Science in Slow Motion, and in this episode they will be showing us how gravity affects an object with different masses. Let's go to Bailey Christopherson with more information. Over to you, Bailey.
Cheyenne Odell, a freshman here at Compass Academy, participating in the Science in Slow Motion project. This project is where they learn about Newton's laws of motion, gravity, and the law of conservation of momentum in slow motion. They have to make a video that explains the science content using slow motion experiments. Cheyenne, what has your group done to explain the gravity part of this project?
We have dropped two objects from different masses at the same height at the same time, and both of them landed on the ground at the same time. This shows gravity because the force of gravity is 9.807 meters per second squared. This means that any mass that will fall at 9.807 meters per second squared, meaning that any object dropped at the same time and the same height, they'll always hit the ground at the same time.
Well, that's interesting. Is the force of gravity the same on Earth and the Moon?
No, gravity on the Moon is 1.622 meters per second squared, while gravity on the Earth is 9.807 meters per second squared. So on the Moon, you weigh far less than you do on Earth. This is because your weight is a measurement of the gravitational pull. Since the gravitational pull is much less on the Moon, you weigh much less on the Moon, and you weigh much more on the Earth because gravitational pull is greater.
Wow, I had no idea. Thank you, Cheyenne.
You're welcome.
Well, there you have it, the latest scoop on gravity. This is Bailey Christopherson coming from Compass Academy. Now, back to you in the studio, Ashlyn.
This is Snotwind News. Be sure to tune in daily for our amazing episodes on science in slow motion.